Hello again. Right, while I'm waiting for paint to dry, literally in the guest room, I thought I'd respond to the request from a few guys to see how the Node-RED version of making Alexa talk back works. I'm going to do this with domoticz, although I think it should apply to most of the automation systems if you can get some kind of Node-RED connectivity with them. So here we have your lovely little Amazon device. I'm not going to describe it because we use its name as the wake word. And what we're looking for it to be able to do is things like this. Echo, door check.
Wait a moment. Something's wrong. Lounge rear door is open.
There we go. It's gone and checked the door sensors around the house and it's come back telling me that one of them's open. Now that's a combination of an Alexa routine, some dummy devices in domoticz, a bit of event code and the Node-RED piece. So let's switch back to the PC and I'll show you how we set up the Node-RED bit. So back at the computer, let's see how we set all this stuff up. So this is the console of my backup domoticz box. I'm not going to do this install on the live one, partly because it's already there and partly because I don't want to break anything. This is a virtual machine, in fact, running under VirtualBox on my Open Media Vault NAS system. So what we're going to do, first of all, because we've got to run a lot of install commands as root, I'm going to do sudo -s. It's not asking for the password because I'd already given that a little while ago. This saves typing sudo on the front of every command that comes after it, and also the odd one where you then forget to type sudo and the command does something unhelpful. A quick apt update just to make sure we've got the latest view of what's in the Ubuntu repositories. This, by the way, is Ubuntu 18.04 server. The same should work on most versions of Linux. Clearly on Red Hat, replace apt with whatever the thing's called on there these days, used to be yast, and so forth. But these mostly should be standard packages on all versions these days. So first of all, it's a node-red node, so that will run on node-red, which runs on node.js. So the first thing we're going to do, install node.js. Do we want to continue? Yes, we do. Thank you very much. And here we go. Hopefully this is going to run fast enough that I don't need to pause the video to spare you watching it. Doesn't look too bad. And I guess at least you can follow along almost in real time. Unless you're running on a Raspberry Pi, in which case it'll take about 5 times as long on past experience. Right, that gives us Node. Now the next thing we need is Node's package manager, which is called npm, Node package manager. Install -G for global, which is one reason we're running as root. We want this package to be available to all users of Node. Node-RED for some reason needs unsafe permissions allowed. Not quite sure why, but it does. I haven't investigated that, I have to say. We're going to install Node-RED onto Node. Oh, sorry. That's interesting. On the other system, npm came with Node. On this one, it doesn't. Okay, so we'll install npm. I'll put these commands up under the YouTube video for you as well, so you don't have to try to catch them as I go through them here. As you can see, I've time skipped a little bit here for you, otherwise this is going to be a seriously long and boring video. It's been about 2 or 3 minutes getting to 16%. I'll switch the video off again and see you at the other end. Right, here we are. It's just finished now. So that's npm installed, bit of a big blighter to install. This does remind me Incidentally, I mean, this seems very slow, and in fact, it's quite hilarious because this is a virtual machine running on top of a Core i5 with a load of memory. So the install is just slow because it's fetching a lot of stuff and compiling stuff as it goes. It's just one of those. Does remind me, if you're running your automation system on a Raspberry Pi or BeagleBone or anything of that nature, Linux writes to log files and temp files constantly, and the lifespan of an SD card as a file system in that sort of scenario is not always very good. So if you are running on a Pi, you'd do well to look at how to boot it from a USB hard disk or something like that before you come to rely on all the fun that your automation system can provide, and then find your SD card craps out and dies one day at an inconvenient moment. And in the meantime, pull the card out occasionally and take an image of it with something to back it up. Now onwards. So we have now Node, and we have npm with which to install the package. So for node-red, so here we go, back to that, and let's install node-red. npm does a slightly prettier job than good old apt. You get this nice little progress bar that draws. Let's just see, I can't remember how long this one takes. You do get a bunch of warnings about parts being deprecated. Don't worry. You can run npm to update all the packages. I'll have to check what the command is for that, but it's worth it afterwards just to tell npm to update everything. And then after npm finishes, it gives you this nice little tree of all the stuff it's installed and how they depend on one another. Right, now we've done that, npm install, globally again, node-red-contrib-alexa-remote. That's the package, the node that we actually want to run. We'll wait for this one, and then we've just got a couple of other things to do to make node-red available. Right, now to make node-red run, we just simply say node-red, and there it goes. And I'll switch around to the console in a minute. Now, in the meantime, while I'm still on the command line, I am just going to show you how to make it run as a service so that it starts up with the system. So we're going to edit using nano, etc. systemd system node-red.service. No file there on Ubuntu. On some Linux versions, you can just tell systemctl to enable the service. On Ubuntu, for some reason, it doesn't give you a service file to start with. Now, this being remote desktop, I can't paste, can I? That's a pain. Okay, we'll do this the hard way. Right. Unit description equal node-red. Try not to make any typos in here. So we're saying it's called node-red. We like it to start after syslog and the network. Now we're going to define what the service is, which is user local bin node-red. Maybe verbose so we get some logging. Restart on failure. Kill signal on sigint. So if you send it an interrupt, it will quit. Syslog identifier is node-red, so that it prefixes its syslog messages with that, so you can find them and send the standard output of the daemon, the service, to syslog. User, never hurts to have a few comments around the place. Working directory, we're going to put it in home domoticz. User will run it as domoticz because that saves problems with access to the domoticz server and anything else that's already set up and working. And install wanted by multi-user.target. Now this is all the systemd stuff, which I have to say is new to me on this last couple of versions of Ubuntu. I am copying that from a web page. I'll give you a link to it. Quit that. Systemctl enable node-red.service. Whoopee. Okay, we're there. So service node-red start. And let's make sure it did. Status. That's fine. The warnings about Raspberry Pi are not relevant here because we're not on one. Right, that's got Node-RED running. Let's flick back round to the browser now and we will go have a look at how to use it. Right, so round on the web browser, let's just get into Node-RED. You notice I've just been in the firewall because I had to allow access from the subnet that my PC sits on to the server for the relevant port. So this thing is sitting on that address and it will be port 1880. There we go, one Node-RED console. Now, if you're familiar with Node-RED, that's great. If you're not, essentially what you do is you stick a bunch of these things together and fill in their parameters and stuff happens. It's great. Down here, you see the ones we want. Alexa, Alexa Speak in particular. Now, what we're going to do, first of all, I'm just going to connect this, which is just, you'll notice I used an inject node here. This is just a trigger. You press the button and it sends a timestamp as the payload, which is kind of irrelevant. It just triggers the flow to start. We'll take that one out for now. That's useful for seeing what comes in when we start talking to real systems. Now, I'm just going to another window open and refer to my live one. So what we need to do here is add some Alexa credentials. This is alexa.amazon.co.uk in my case. .co.uk. Now the cookie, this is where it gets interesting. We have to go find the cookie. So we're going to go to Alexa page and it will log in. And then we're going to right click the page. Do you see the right click menus come up on the video? No, unfortunately. Okay, I'm going to right click the page. This is Firefox, similar applies in Chrome, and inspect. In Firefox it's called inspect element. Now somewhere down here what we have to find, we go to network and we look at these GET requests, HTTP requests. We will find in one of them the right cookie. We want the headers, sorry, not the cookies, we want the headers. There we go, there's the cookie. But essentially what you have to do is click in here and you'll see there is just the faintest hint of a cursor caret there. And then if you go to the right, it will scroll. And you just wait for it to finish scrolling all the way over. This is not so much a cookie as a 4-course meal, I think, this one. There we go. Go here, paste that lot in there, and add. There we go. Right. Now, we can set up an echo device. So, oops, I shouldn't say that too loudly or it'll start responding to me. That's that. The serial or name is the name given to your Alexa device when you've set it up in Amazon. They all have nicknames. That's just a name for the node as it appears in the Node-RED workflow. The text is what you want it to say. So So we'll have something a bit Michael Caine. Volume is somewhere between 0 and 100. Deploy your node. Successfully deployed. Let me bring our little friend the device over where you can hopefully hear it, and let's see what happens. Oh. There you go, a bit slow with the first connection. If you didn't hear that, here it is again.
Where it only bloody works.
I think it'd sound better if it had a Michael Caine accent, but there we go. That is your basic workflow. Now, if we want to connect that to domoticz, the easiest way to do it is to take MQTT as your input instead of the timestamp. And then because that comes in as JSON, we just need to find the JSON interpreter node. So I'm going to get rid of that. I'm going to take the MQTT, connect it to the JSON, connect the JSON to the echo. Now at this point, the debug comes in handy, because if you connect that also to the MQTT, you can see what's coming in. MQTT, let's add a broker. So this needs to be for various reasons, mine won't respond to localhost, so we'll do it on its proper IP address. I don't have security on that server at the moment. And the topic we don't need to set, those are just last will and testament stuff. The topic here we do need to set, so oops. I've decided to use a different one to domoticz's normal ones. Domoticz uses domoticz/in and domoticz/out for devices reporting in and being told what to do. I've opted to use something different so we don't cause any confusion. If you wanted this to monitor in domoticz the state of a device and react to the state of a device, you could plumb this together, monitoring domoticz/in or out, whichever it is. I think they're back to front. And the relevant device, so it's domoticz/in or out and then monitor for the IDX once you've interpreted the JSON. So you could then use a function node here to, or a switch node actually, sorry, better, to check the IDX value in the domoticz message. Similar things will apply with anything that's using MQTT, I presume. There are also, you can see, various ways of getting it triggered over here. You can get it triggered by HTTP, WebSocket connections, TCP, raw connections even. So if you've got some of the other automation systems, Vera, etc., it's not hard to poke an HTTP address from a bit of LUA code in a Vera, or indeed you could install one of the HTTP switch type plugins and have that poke it as if it's turning on a switch that would actually then trigger the whole node-red flow. So let's deploy our flow. Right, you can see here serial or name in that format and text all in lowercase. Those are the two things it's expecting. If I take out my text now and my serial or name, we can command any of the half dozen Alexa devices in the house. There's only one sitting here next to me where you can hear it, so we'll be using that one for now. Right, now we need to switch back to the console and we need to install a couple more tools for. Okay, here we are back at the Linux console on the domoticz box. Now, I've discovered something that's worth knowing. The Mosquito client programs, Mosquito Pub and Mosquito Sub, seem to come in two flavors on new versions of Ubuntu. One is one of these so-called snap packages, and you'll know that because you'll find Mosquito Pub or Sub if you ask Unix which mosquito pub or sub, it'll tell you they're in /snap/bin. There seems to be a problem with that version of mosquito pub in that it can't read from files, and the technique I'm using to generate the message JSON text here uses a file. So that's not a terribly helpful thing. The version you want is in a package called mosquito-clients, and if you install mosquito-clients, you'll find mosquito pub then lives in user bin mosquito pub and works, importantly. Now what we're going to do is to send the JSON to our node-red workflow. So as you'll recall, we have serial or name for the name of the Alexa device we want to speak, and text for the text we want it to speak. That's what the JSON looks like. You'll notice that JSON is, frankly, when you're dealing with the Linux shell, JSON is a damn nuisance because it's full of quotes and curly brackets and colons and things that the shell will try to interpret. So I've opted not to try to type this on the command line because no matter what I try, escaping quotes within quotes never seems to work properly. So I put it in a file. What I'm then going to do is to say mosquito pub -h for the host, so that's this host, minus T for topic, domoticz/speak. You'll remember my domoticz node in node-red, I told it to look for that topic, minus F to tell it to read for a file, and that file message1. Here we go. Oops, I'll come off it. That's the error you get if it runs the wrong version of mosquito pub. So we'll just specify the right version.
Well, blow me down. Another success.
There you go. Alexa's dulcet tones. So that's how that works. Now I'm going to switch over to my live domoticz box and show you the script I've created and just demonstrate that. And then I'll show you the domoticz dzvents event that calls it finally. So let's, okay, not sure quite how well this is coming up on the video recall, but let's hope you get to see enough. So here we are in my scripts folder, and that's the script. Anybody wants this, just drop me a PM and I'll happily send it to you. You can see here what we're doing is just taking in as $1, the first argument to the script, the name of the Alexa device, and $2, the text to speak. Then we form the JSON into tempf, a temp file. We run mosquito pub, as you saw me do on the command line a moment ago, reading from that file. And then actually I haven't finished tidying that up after debugging it the other day. We should clean up after ourselves and remove the temp file. So if I do this /speak sh, study echo, from the speak script.
Hello from the speak script.
Hopefully you heard Alexa's dulcet tones once more. That's what we're calling from domoticz events. So we just put out an os.execute from the LUA code for speak.sh with whichever echo device we want to speak and the text we want it to speak. Now, whatever you would do with other automation controllers, I mean, if you can put a script like that on your file system and call out to it, great. If you can't, you just need some way of generating that MQTT message, or as I mentioned earlier, start your node-red flow with, say, an HTTP node, which you can then poke from a dummy script. Now I'm going to switch over to the domoticz UI and just show you one other aspect of this, which is the event that I've used, or one of the events that I've used to drive this. So what we have here is exit check, an exit check is triggered by a routine which I can't show you because it's only accessible from the Alexa app on mobile phones for some reason, not from the web one. But I have an Alexa routine which, if I say door check to one of the devices, sets a dummy switch, in fact it's a dummy push button so that it turns itself back off again in domoticz called exit check, and you can see that here as the trigger device for the event. And then what we do simply is we have an array here of devices and the states I'd like them to be in before I leave the house, i.e. I'd like all the doors to be closed. Might have to remove the front door from that at some point because that's more likely to be open if you're about to leave. We set a speech string to nothing to start with. We go through the array, and if we find something is not in the state we want, we say add to the speech string. The name of the thing is whatever state it's in, and notice there the 4 commas to make the blasted thing pause. Otherwise you get the front door is open, the back door is open. Alexa's always in a hurry for some reason. If the speech string is nothing, so we haven't found any doors in the wrong state, then we change it to all looks good, goodbye. And if it's not, then we prefix it with wait a moment, something's wrong, and then she explains what's wrong. Speech device here, I'll leave this as study echo for a moment. This actually needs to be the whole one. And then as you can see, we form a string very much like I just typed into the command line to execute the speech script, and then os.execute that script, and then we just test the return value and log if it did anything strange. So this event then should generate the effect I showed you back at the top of the video. Let's just try it once more. Echo, door check.
Sorry, I don't know that.
Typical Alexa response. Echo, door check. I think I may have picked a string that's a bit hard for it to interpret.
Wait a moment, something's wrong. Lounge rear door is open.
There you go. The lounge rear door is probably not open. In fact, it's an Eon Labs sensor that's a little bit far from its magnet, which I need to move, but it's a good warning of what's going on. I have other uses of it as well. There's what the fire alarms do. So when our fire alarms go off, the ICO alarms have a relay module which I've connected to a Fibaro. I think it's Fibaro. Might be a Everspring Z-Wave switch module, which gets picked up in domoticz as having changed state, switched on, and this code here picks that up, sends out domoticz notifications, runs a scene that turns off the ventilation and the boiler and stuff like that, and then we run a script called firealarm.sh, which basically puts itself into background on the Linux system and calls the speak script to say there's a fire, get up and get out, every 20 seconds for 2 minutes, which really, really annoys my son. It's quite funny. But apparently voices are much better at waking people up than squeaking fire alarms, so I thought we'd give that a go. That is it. That is how you make Alexa speak, at least the version that worked for me. There are several versions of this thing. There are a couple of shell script versions, and as one of the guys pointed out to me the other day, there's a node-red-Alexa-remote 2. They all have other features. So this event then should generate the effect I showed you back at the top of the video. Let's just try it once more. Echo, door check.
Sorry, I don't know that.
Typical Alexa response. Echo, door check. I think I may have picked a string that's a bit hard for it to interpret.
Wait a moment, something's wrong. Lounge rear door is open.
There you go. The lounge rear door is probably not open. In fact, it's an Eon Labs sensor that's a little bit far from its magnet, which I need to move. But it's a good warning of what's going on. I have other uses of it as well. There's what the fire alarms do. So when our fire alarms go off, the ICO alarms have a relay module which I've connected to a Fibaro. I think it's Fibaro. Might be a Everspring Z-Wave switch module, which gets picked up in domoticz as having changed state, switched on, and this code here picks that up, sends out domoticz notifications, runs a scene that turns off the ventilation and the boiler and stuff like that. And then we run a script called firealarm.sh, which basically puts itself into background on the Linux system and calls the speak script to say there's a fire, get up and get out, every 20 seconds for 2 minutes, which really, really annoys my son. It's quite funny. But apparently voices are much better at waking people up than squeaking fire alarms, so I thought we'd give that a go. That is it. That is how you make Alexa speak, at least the version that worked for me. There are several versions of this thing. There are a couple of shell script versions, and as one of the guys pointed out to me the other day, there's a node-red-Alexa-remote 2. They all have other features. If I go back to Node-RED, you can see they're able to command Alexa and make it play music as well. I've not tried those. Good luck. Post on the Facebook group maybe if you get them working and it's cool. But the speaking is really handy. Hope that's been informative, and goodbye.